Thank you. And hi, everybody. So yeah, my name is Guillaume Molter. I'm a senior web and application developer at the Harvard School of Public Health. You have my email, GitHub, and Twitter handle if you want to reach out. And as you may have guessed by my first name, I'm French. Today, as you may know, is Bastille Day. It's our 4th of July. So I thought instead of talking about AWS, I would talk about the French Revolution. Just kidding. A few disclaimers. I don't work for Amazon. I didn't receive any money to give this presentation. You should not necessarily use AWS for your project. I'm not here to tell you that AWS is like the best hosting service in the world. There's plenty of other hosting company, cloud providers. I'm here to tell you, okay, what happened to us is my boss came to our desk one day and was like, hey, Harvard just signed a big contract with AWS. We need to move everything to AWS. So if that happens to you, what should you do and how should you do it? That's going to be today's talk. AWS currently, as I was preparing this presentation, had 98 services available. We will not be able to cover all of them. So I'm just going to focus on the one we are using at the School of Public Health for our WordPress infrastructure. And finally, I'm human. I make mistakes. I sometimes say stupid things. So if you think I've said something wrong or anything, just feel free to chime in at the end of the presentation and give your point of view or correction at the end. All right, a little bit about why I'm here. So we manage a lot of, I work for the web team and we manage a lot of different products, but definitely our main product is the school website. It's a multi-site installation with a little bit over 1,800 websites. We have around 100 plugins and 15 themes. We receive around 1 million visitors per month and 170 million hits per month. But the specificity about this traffic is on a daily basis, we actually have a pretty low or average traffic, but we also have a lot of traffic spikes. The school does a lot of live events, forums, of any kinds, plus you have all the academics, natural events like commencement, etc. That suddenly drives a crazy amount of traffic to our website because everyone is wondering where the parking is or where that tent for commencement is, etc., etc. And we also have a lot of magazines, so whenever a new article is published, suddenly we see a whole bunch of traffic. So we need a hosting environment that is able to scale up and scale down very easily to handle that very varying amount of traffic. And finally, Harvard, big name, we're a prime target for hackers, and we obviously need to take security with a lot of concern. All right, let's take a look at this is currently our production environment for this website. If you don't understand anything or not everything, that's good because that's why we're here today. I'm going to take a look at each service one by one and talk a little bit about what it is and why it's here. Also, a few basics about AWS and hosting in the cloud. Two terms that you're going to hear everywhere if you start looking at AWS is scalability and elasticity. Those two terms have a lot of common ground, but basically elasticity means the ability of your hosting environment to go up and down depending on your traffic, so on a very short term, where scalability addresses the need for your environment to be able to scale with your business. Especially if you're in a multi-site environment, chances that this network is going to grow over time. So you need a hosting environment that is also able to grow with your multi-site network. When you're in the cloud, you usually geographically, not everywhere, but you have the ability to be everywhere. AWS use two terms to address that. They talk about regions, which are like basically continents or part of a continent. And inside of those regions, they have availability zones, which are smaller parts of those regions, and which usually means you're going to be on another server rack if you're on two different availability zones. And finally, whenever you build something in the cloud versus trying to have like one big server, you're going to try to have like smaller part and get rid of single point of failure. So you're going to build everything around resiliency and redundancy, having small little bits of servers, small little bits of resources, but that are redundant. And so if one fails, you have another one to take over. Okay, now let's talk about actually hosting WordPress on AWS. So obviously, the very first thing you're going to want is a web server. So for this, you're going to use the basic Elastic Cloud Computing instances of Amazon, which is their little virtual servers. They come in different types, in different size. The price obviously varies depending on what you're going to choose. And here, the idea is to select the smallest instance possible that is going to handle your average usage of your website. And we'll talk a little bit more about that. And you also usually have a number, which simply means the generation of that instance. So now we have the server itself, but what about and I've put LAMP because that's kind of the most popular, but that could be Nginx or anything else that you want to put on it. So to provision your instance, to put an actual operating system on it, what you're going to do is using an AMI. An AMI is like a snapshot of a hard drive that you put on that server. And you have a whole bunch of different AMIs available. You're going to have the very basic ones that just have like just Linux, and you install Linux, and then you have SSH access, and you do whatever you want on it. You're going to have some community-free AMIs that come with a full stack. So you're going to have LAMP, etc., all of it installed and ready to go. And you're also going to have some commercial ones where you're going to pay a little extra fee on the price of your EC2 instance to have an AMI full ready and supported by a private company. So in our case, we use the basic one with just Linux. And then what we do is we use something that AWS called user data script, or other cloud provider, and the Linux world usually refers to it as cloud init. And it's basically whenever your instance spins up, you can pass it a script and tells it what it should do when it's launching. So that's what we use and we have a big bash script that is basically installing Apache, installing PHP, et cetera, updating the system, and all of this. So at this point, we have a fully operational web server. But now we need WordPress. So to do that, again, AWS offers a whole bunch of services. Code Commit is going to offer you the ability to host private Git repositories. Code Build is going to allow you to run tests and builds. Code Pipeline is basically a service that is going to move your code from one service to another. So it kind of goes on top of all the other ones. But certainly the most important one is Code Deploy, which is actually, and by important, I mean the one that you will have the most trouble getting rid of and using something else, is Code Deploy. And Code Deploy is the service that is actually going to grab the code and deploy it on your instances. So again, redundancy. When we build something in the cloud, we don't want one big single point of failure. And right now, we have a web server, we're running WordPress, but it's just one web server. What happens if it fails? So we're not going to have one web server. We're going to have multiple ones. And what we're going to do that is we're going to need two other services. First, an Elastic Load Balancer, which is going to take the incoming traffic and distribute it around multiple instances. And then we're going to use another service called an auto-scaling group. And the auto-scaling group is going to basically make sure you always have the correct amount of instance based on your traffic. So it's going to bring in new instance when you need them and kill old instance when you don't need them anymore. Again, we'll address this a little bit in more detail in a few slides. So you're going to tell me, but wait, if I have multiple web servers, where do I put my database? And if when this instance is getting shut down, I'm going to lose my database. I'm going to lose my data. So what you're going to do for this is you're going to move your database outside of your standard web server. You're going to move it to most likely a service called RDS. RDS are basically EC2 instances, but they are fully managed and optimized for database hosting and they're fully managed by Amazon, secured, etc. So for those instances, you're not going to get any SSH access or anything. You're just going to say, I want MySQL. I want to do snapshots every hour, every 10 hours, etc. And they give you just the root password and database access to a MySQL server. It's fully run, backed up, etc. by AWS. And just like EC2 instance, they come in multiple sizes and multiple types. So again, we don't want one single point of failure. So we're not going to have only one database instance. What we're going to do is use natural feature of both MySQL and RDS, which is a system with the master and some read replicas. So we're going to have our big master database that handle the read and writes from WordPress. And then we're going to have a couple read replicas, smaller instances that only serve reads queries to WordPress. And to do this, we use HyperDB, which is a WordPress plugin that you're going to install, and that's going to make WordPress aware that there is multiple database and that WordPress should route the queries, depending on what they are, to the correct, either to the master if it's a write query, or to the read replicas if it's some selects and things like that. So we've dealt with the problem of our database, but now we also have a problem with uploaded files, because uploaded files naturally are uploaded to web servers. So we have the same problem. Your uploaded files are spread across multiple servers, etc. So to deal with that, we're going to use Amazon S3. So S3 is a file storage system with high resiliency, high redundancy, and really good performance, and actually reasonably cheap. It's used by the entire Earth, and whenever it fails, you usually know it because the entire web, is basically down. So what we do is we move our upload folder to S3. To do this, we use two WordPress plugins that actually work in a pair. WP Offload S3 that takes care of moving your upload file to S3. So whenever someone uploads something in the media library, the file is moved to S3, and the plugin also takes care of updating the database link to that file, etc., doing the link for you. And this plugin has a requirement. It requires its parent plugin called Amazon Web Services. And we also use another service called Glacier. Glacier is their cold storage solution. So it's a cheap way to do some very large backups. The only problem with Glacier is the time to retrieve files is super slow. So we really use it for the disaster recovery backup. This is not a way for, oh, I deleted that PDF, can I retrieve it? No, sorry, it's gone. But however, if for some reason, S3 was to fail completely, or if a hacker was to get access to our S3 bucket and delete old files or something like that, we would have at least a backup somewhere that we can retrieve and restore. Okay, now we've dealt with our web server. We have a functioning and scaling stack. Let's try to speed things up a little bit. So the first thing we're going to do here is to implement a CDN solution. So we're going to put a service between the user and our S3 buckets. So the S3 buckets, again, are distributing static files. So we're going to use CloudFront in the middle. CloudFront is Amazon's CDN solution. It's located in multiple locations, and it acts as a big cache in the middle to limit the distance between the file and your user, and to serve it much faster. It's also, if you have a large website, also going to allow you to save a lot of money, because a lot of S3 queries can get pricey on the long term. The other thing we're going to implement is caching. To do this, we're going to use another AWS service called Elasticache. Elasticache, just like RDS, is a fully managed, optimized caching solution offered by AWS. They offer two solutions, Redis or Memcached. In our case, we're going to use Memcached. Again, they come multiple type, multiple sizes. Something I forgot to mention, the type refers to actually, so the M is always the standard one. And usually the other layers are CPU optimized, memory optimized, or sometimes you have burstable, which is like when you don't use all the resource, you accumulate some credits, and whenever you need a little bit extra resource, you don't pay extra and you can use that credit. So back to caching, again, we're not going to have one node, we're going to have a couple small nodes that are also going to allow us to reboot them whenever we need without taking down the entire caching system. And so Memcache is going to go in between your EC2 instances and the database. And to use Memcache, we're going to use two plugins. The first one is Memcache Redux. And Memcache Redux is going to do some object caching for us, which means WordPress is going to use it to store the most commonly queried objects to prevent querying everything from the database over and over and over again when you have some redundant queries. And Bad Cache is going to do some full page caching. So it's going to store a page if it's requested too often. It's going to store the full page in cache and serve it directly to the user versus regenerating the entire page. And Bad Cache has a dependency on Memcache, not Memcache Redux, but some kind of Memcache plugin. You need to have already implemented Memcache to be able to use Bad Cache. A few words about security. You may have seen or heard about VPC, which stands for Virtual Private Cloud. You have to see a VPC as a box into which you're going to put your environment and protect it from the outside world. So what you're going to do is separate all your resources inside of that private cloud. So if you have multiple environments, like a production, development, staging environment, usually good practice is to put them in separate VPCs. So again, if someone gets access to one VPC, they can't go, they can't reach to the other resources. The same way, if you're hosting multiple websites on multiple hosting environments, you're going to want to put them also in separate VPCs. It's like an extra layer of protection. Security groups, by default, your AWS resources are not going to be able to do anything, interact with each other. By default, your EC2 instance will not be able to talk to your RDS database. You're going to need to create a security group which explicitly says, hey, I want to allow this EC2 instance to talk with this RDS instance. And that's going to be the same for every single resource you create. That's can be a little painful, but on the same time, it's really, really good security practice because you're going to need to open the doors one by yourself so you kind of know what's open and again, if someone get access to one resource, they have a limited access to the other resource inside of your VPC. Encryption and certificates. AWS is really, really good to encouraging encryption. You can almost encrypt everything nowadays, including database files. Everything can be encrypted. They usually give you full access to the keys and everything. And same thing for certificates. They have now the certificate manager, which allows you to create some free SSL certificates. It's still a young product and it's still pretty limited into where you can actually use those certificates. So it still needs a little bit of work. But yet it's really cool to see that they're really pushing this forward, and it's not yet a good enough alternative to Let's Encrypt, but they're doing something at least about it. And finally, IAM, it's their identity management solution where you can create users, you can create resources, groups, and once again, you're going to need to create policies to tell what those users and resources and groups can do inside of your AWS account. By default, whenever you create a user for someone, they will not be able to do anything on your AWS account. And this way, you have a really cool way to restrict access to who can do what, etc. And we still have some users that insist on having a web FTP to be able to put HTML files that they've created themselves. We've used S3 with some super restricted IAM users to do that, and it's been working great, and we don't need to have a web server for this. And yeah, there's some really nice and ways to tighten your policy there. Another important security feature that we've been using for a while now is using a web application firewall. So we don't actually use the Amazon WAF, but they now have a full solution. The web application firewall works exactly just like a regular firewall, but it's made to protect a web application instead of a full network. And you're basically going to be able to filter and create rules about who can actually reach your application. So you're going to be able to, block some IP class, some IP ranges, some geographical regions, etc. And now AWS also has a DDoS protection solution that can go on top of that WAF solution. And that's obviously going to allow you to protect your service, but also save a lot of money, because since you're paying by the resources you're using, you probably don't want to receive all the bots, traffic, and stuff from, and that will just virtually increase your monthly bill. So that's a good way to both protect yourself and save some money. Okay, now we have a stable, optimized, redundant, secured AWS hosting. Now, how do we keep an eye on it? How do we make sure everything works properly? Again, AWS has half a dozen services for monitoring. You have a couple ones here on the screen, but here the most important one for us is going to be CloudWatch. CloudWatch is the central monitoring solution for AWS. It's going to pull data from your EC2 instances, your auto-scaling groups, Elastic Load Balancer, database, all the services you want. And based on that, you're going to have metrics, and you're going to be able to create alarms based on those metrics. And one last thing that CloudWatch does too is actually store logs. Again, if we have multiple web services, our logs are going to be spread out on multiple on those web servers. So you have 4 or 5, Apache logs and 4 or 5 PHP logs, which can be a little tricky. Well, CloudWatch is going to be able to grab all those files, put them in one location, and allow you to search into those centralized logs. So how does that work? So when we provision our instances using our bash script, we install the CloudWatch client on those instances so they know they need to push their logs and data, etc., to CloudWatch. So they're continuously streaming data to CloudWatch. And CloudWatch, whenever it realizes that the CPU on your instances go too high, or your load is too high, your memory is too high, whatever alarm you've defined, it's going to trigger an alarm. And the alarm is going to do 2 things. It's going to tell the auto-scaling group, hey, you should do something about it, because this alarm just was triggered. So your CPU is too high. We need to bring in a new instance. Or your CPU is too low. It's time to get rid of an instance that we don't need anymore. And the other thing that the alarm is going to do is use another service called SNS, for Simple Notification System. It's going to send a notification to a distribution list you've created. And you're going to be able to send text messages, emails, Slack notifications, etc., to a group of users, depending on the time, etc. You're going to be able to say, hey, at that time, if a scaling event happened, I want to warn those people, etc. So you're going to be, again, you will have to configure all this, but you're going to be able to tell her very precisely what you want it to do. All right. I'm sorry for the fast pace, but it's a lot of things to cover. Let's go back to our little schema. So we have on the top left our web user. They're talking to Harvard DNS. Harvard DNS will send them to our WAF. If the WAF determines it's, good traffic, it's going to send it to our Elastic Load Balancer, which is inside of our production VPC. The Elastic Load Balancer will distribute the traffic between, right now, 3, sometimes 4, sometimes 5 instances, depending on the current traffic. And those instances are going to send some queries to our different databases and our Elastic Node cache. If, however, the user requested a static file, which an image, CSS file, JavaScript file, you name it, Harvard DNS is going to send them to CloudFront, and CloudFront, if they don't have the file in their cache, will query that file into our S3 buckets. And we use CloudWatch monitoring to monitor the entire infrastructure. And whenever our development team work, they push code to GitHub. This code is pushed to our CI/CD system. We currently use Circle CI, and Circle CI runs some tests, etc. And if the code seems correct and good, it's pushed to code deploy, and code deploy will deploy the code on the different instances. Okay, as you can see, it's a lot of services, a lot of configuration, a lot of time to put all this together. One thing we learned way too late is that AWS has this wonderful service called CloudFormation. And CloudFormation is going to allow you to create a JSON template of your entire infrastructure. And so you're going to be able to, that schema we were looking at, you're going to be able to describe this as a big JSON file. And whenever you need to launch this, you're going to simply click on a button, say, hey, launch me this stack. And it's going to create all the resources and configure everything for you, etc. And when you need a staging environment, you're going to be able to say, hey, I want to launch a second one. And one click of a button, you can have a couple questions, ask you how many instances do you want, or is that a production or staging environment, etc. But overall, it's going to take a few seconds to launch an entire environment. And whenever you have, this research group or whoever approaches you and say, hey, we would like to have our own WordPress stack in the corner because for some reason we can't use the school's main website, well, you're going to be able to launch them an entire hosting stack again in a click of a button. And when you decide you want to make a change to your infrastructure, again, you're going to just change your template and say to AWS, I want to update my existing stack based on that new template, and it's going to update the existing stack. So it's a wonderful service. It takes a little bit. It's obviously a big JSON file, so it's going to take a little bit of time to get used to it and to properly organize it. But once you know how to use it, it's really, really, really useful. All right, again, sorry for the fast pace. At this point, I would like to welcome any questions. You have a link to download the slides if you want, and please, if you liked or hated that presentation, please fill out the survey online or the paper one. Thank you very much.
What kind of EC2s do you actually recommend for application hosting? Like the M's, the R's, C's?
So it really depends on your use case. The M is usually, so that's their standard, and I would recommend starting with the M because that's kind of their standard and cheaper. And what we did is we also use New Relic for monitoring, and we took a good look, a good look at the CPU and memory usage of each service. And for some of them, we realized because users were doing a lot of uploading images and resizing, etc., that we needed more CPU, or some others were more relying on memory. So for those services, we decided to switch the type of instance. But I would definitely recommend starting with the standard one, looking how your service evolved. And again, if you've used CloudFormation, it's as easy as just going in a template and changing the type of instance, and one click of a button, and you've changed everything to your, your entire stack is updated to your new type of instance. So.
Just wanted to add a comment to that. I think it's also about how you want to move forward, whether you want to do vertical scaling or horizontal scaling in terms of the multi-site, because we ran into that same issue that initially when we had the slowness or compute issues or performance issues on our system, we were trying to do horizontal scaling by adding more nodes with less of CPU or less of memory both, and we ended up facing that that was actually an issue because of that. So then we had to step back, we had to go do vertical scaling by adding more CPUs and more memory, and then reducing the load. So I would say it's definitely something that you might want to start experimenting and then explore. I had a question. So when you mentioned that you're using S3 for static assets, is that something that you have had issues in the past with some plugins behaving inconsistently? Because we had that previous
So we had a couple problems, mostly with plugins that do like after the fact image resize and things like that. This has been mostly corrected now because the new media library has a cropping solution, and we tend to favor plugins that actually rely on the native cropping solution rather than after the fact. But yes, it's definitely something to consider. There are some plugin incompatibility with having your files. Basically, anything that is going to need to change the file afterward is going to be a problem if it's stored on S3. So what we usually recommend in that case is to either re-upload the file or to do the change manually on the computer or things like that, which is not necessarily ideal. I know that Delicious Brain, the development company behind the plugin we're using, are trying to address this problem right now to try to find a way to retrieve the file, change it, and re-upload it. But I'm not sure how, like, where they are in terms of that development. But yes, it's definitely a.
Sure, yeah, because I could also think of like a lot of unification plugins might also create issues if they wanted to make changes to the files. And have you considered EFS for this or trying to address that?
Nope, I'm not sure. So what is EFS?
So that's for S3 is like a low-cost option for storing objects. EBS is like having it on your own node, and EFS is something that I mean, this is again, I'm just trying to learn more about EFS at this point.
Okay.
EFS, they say for AWS is something that gives you kind of a somewhat virtual EBS, but that is fast, similar to EBS, but also accessible to all the nodes in the same file system. So kind of benefits of both EBS as well as S3. So
Okay.
people also say it's a bit expensive, and I don't know if there's any issues with that.
Yeah, I unfortunately haven't looked into it yet.
So it's basically a mountable portfolio. You don't have to mount just one server.
Okay.
The issue with it is very slow and expensive in the beginning, but as you add more data to it, archive files to it, it progressively becomes faster. But it gets to that point, it gets very expensive.
Okay.
So that's the caveat.
Like how big? Like you're looking like in 10.
Yeah.
I have a question related to plugins.
Yep.
So you noticed that you were using Memcache Redux, Batcache, the AWS plugin, and then its sister S3 plugin.
Yep.
And I'm curious, because like I've gone back and forth my own hosting packages between that and just using the W3 Total Cache, which does caching and minification and CDN integration. Like, how come your organization chose to go with the suite versus a single solution?
So the question is, why did we, I forgot to repeat the previous questions, but the question is, why did we choose to use Batcache and Memcache for caching mostly and not like double? So unfortunately, I can't really answer that question. It's my colleague who's not here today, who I was not there when they decided to implement Batcache and Memcache, so I'm not really sure what drove that decision, and we haven't really had any major problem with Batcache and with Batcache Memcache combo so far. So we haven't really got a chance to choose, to look for different solutions. Now that said, I know that there's plenty of other caching solutions out there, and plenty of them are super good. So I'm not necessarily recommending Batcache or Memcache. It's just what we've been using and haven't had any problems. But yeah.
Okay.
Any more questions? Yes, we have. So to go back a little bit in the history of AWS at our school, we used to have an external hosting company with which we had a lot of problems. And when Harvard Central signed that big fat contract with AWS, again, our boss came and was like, hey, we need to move everything to AWS. However, when we're doing this, we have a server team with server admins, but they were like really busy on another project, and they basically didn't really have time to deal with it. So we kind of like inherited the AWS hosting part, which was really fun, and I loved doing it. It was very interesting, and I knew just enough about hosting that I wanted to take this over, but I was not necessarily like a hosting guy. But so now we're at a point where we would like the server team to take back a little bit of the maintenance of that infra, because at the same time, we also have our development job to do on a daily basis. But yeah, we're definitely, I would love to look at other solutions, even, things like Chef, Puppet, and everything that could make our life easier. So I was mentioning at the beginning that you use an AMI to launch your instances, to launch the actual system, and that we use a bash script to like provision that instance. You have some really cool services like Packer, for example, that allows you to actually have your script, but then generate the AMI and store that AMI ready to go. So you don't need to wait for the AMI to provision every time you start a new instance. And that's like a really cool service that we love to use, but unfortunately haven't had really time to look into it so far. But yes, definitely. All right, well, thank you very much.